All right, fellow mathematicians, we're going to take a look at ln of pi. How do we estimate that? First of all, what the heck is ln? Ln, log naturel, or whatever, however the French say it, is the natural log. And so what is the natural log? What the heck does that even mean? Well, remember that if you have a log of some number, say 100, then you're supposed to know that the base is 10. And so you can say, hey, this equals 2. Well, what does ln mean? Well, ln, let's say, let's just stick with 100. It's not the same, but whatever. ln of 100 means log base e. That's what that means. Okay? So log ln of pi is really log of pi base e. And if log of pi base e is what they want, we're going to use our graphical estimation skills to make an exponential curve with the e, and then we're going to make a horizontal line for the constant of pi. And wherever they meet, that is our solution. Let's try that. Yes, let's try that indeed. You know what? Let's go to the graph because it's better. Yes. Yes, 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 yes. Oh, I didn't mean to erase that one. It's fine. So we have log of pi base e. And so let's start with the e. So this is going to be y equals e to the x. And that looks something like this. We know 0, 1 is a point. If you plug in 1, you get e, so that's about right here. If you square it, you get like 8 point something. So that's like right, oops, I'm off. It's like right here, approximately. Okay, and then to the -1, that's like a little bit more than a third, so that's like right here. And then it just kind of trails off. So let's try to roughly freehand this with my horrible, awful graphing skills. Which, wow. For once, that for me is really, really good. Pi is, of course, right here, approximately, right? Pi is just a little bit more than 3. Again, we're just kind of freehanding this. That's okay. We're looking for an estimation. So let's draw that constant here. So this is going to look something like this. And that's just going to be good enough for us. And where do they meet? A little bit to the right of 1, I'd say. Right? Sure. I think even less than that. That's like 1.2 or something, or 1.1 something. Let's just say 1.2. It is too much. It's not 1.25. It's not even a quarter. A quarter would be halfway in this box. So I'm going to say 1.2. So that means that this right here is approximately equal to 1.2. How about that? Before today, would you have been able to estimate the natural log of pi? Probably not. Maybe Google, yes. but not yourself. And certainly not without a calculator. Maybe even not with a calculator. But here we are. One more? I wouldn't. Of course I wouldn't. Who said I would? No. No, I wouldn't. No, I wouldn't. And even this one here, it looks hard, but it's really not. Especially when you realize that you're just estimating. Because pi, I mean, is it really that different from 3? Not really. I saw this great video about how pi is 4. I don't want to get us sidetracked. Let's just stick with the math. But it was really funny. Hassenfelder, look it up. Yeah. So remember again, the two different equations we're going to make is y equals 2 and y equals 1 over pi all to the x. Okay. Well, this one here, you realize that 1 over pi is really pi to the negative 1. And we're taking this to the power of x. Should we mess with that? Yeah. No. I kind of just prefer to leave it as 1 over pi, actually. Let's just do that. We're going to graph 1 over pi to the x. One over pi to the x. And what you're going to realize, I don't know if you know this, but what happens when you have an exponential graph with a number between 0 and 1? What happens if you do an exponential graph with a fraction? Are we aware of this? If I have y equals 1 over pi to the x, let's do some math on that. Actually, let's start with a different one. Let's do y equals a half power to the x. Maybe for you guys to get the idea. If you plug in 0, you get 1. If you plug in 1, you get a half. If you plug in 2, you get a quarter. If you plug in 3, you get an eighth. Do you see what's happening? It's getting less steep, actually, as you go from left to right. Yes. It's approaching 3. It's 3. It's approaching 0. It's approaching the x-axis. It's asymptotic. Asymptotic, one or the other. It's approaching the x-axis on that side. And you know what it's doing on the left side? What's negative 2? What's a half to the negative 1? A half to the negative 1 is 2. A half to the negative 2 is 2 squared, which is 4. So that one would go right here. And a half to the negative 3 is 2 cubed, which is 8. So that one would be right here. And so this graph would look something like this if I were better at graphing, which I'm really not. That was really bad. I wish there was like some way to automatically do it. Anyway, point is, this is the basic shape of it. It's going to slope downward. Well, 1 over pi, I'm just going to freehand this, but this one's going to be a little bit steeper. So this one's going to come in like this. And actually go under, but my graph is not very accurate. But the point is, it's going to look something like that. And then the other one was, what was the other graph again? It was y equals 2. Okay, so this is a really awful graph. My blue graph is really, really awful. I really don't like it at all. I really am ashamed and embarrassed about it. But you know what? That's going to be good enough. That my awful, awful, horrible graph that sucks is going to be good enough because I got the basics right. Because I got it. I got this part right here. This is one of the most important points. You have to get the y-intercept right. Okay, so now if I graph y equals 2, check this out. I know that y equals 2 looks something like this. And where do they meet? They meet right here before 0. Right, in terms of left and right. In terms of how far left and how far right. This is negative. This is going to be a negative answer. And the question was simply, is it positive or negative? And we have to say that the log of 2 base 1 over pi is negative. And I don't think you would have realized that just by looking at it. Just by looking at log of 2 base 1 over pi, you would not necessarily have realized that that's a negative number. But here we are. Our estimation tells me that this is a negative number. How about that? Is that a good place to stop? I feel like it is, although this one looks really nice. Should I do one more?
Yeah.
Only have 3 minutes? Ah, all right. Well, my friends, another wonderful video. Please like, share, and subscribe. Do your homework. Please engage. Make a comment. Tell me below what you liked about this video. And tell your friends. Thank you very much, everyone. See you later.